All right, so quick review from Friday. We went over the idea of the mole, okay? And a mole is a unit of measurement that tells us how much of something there is with reference to how many particles of it there are. All right, so in similar way to mass and volume, the mole measures how much of something there is of a material, okay? So we said that in 1 mole of anything, regardless of what it is, okay, 1 mole is this many. 6.02 times 10 to the 23. Okay, if we're talking about an element, then it's that many atoms. If we're talking about a compound, it's that many molecules. Okay, everybody follow me there. Now, if I'm looking at, let's say, lithium, 1 mole of lithium would have a mass of 6.94 grams. But if I look at something else, like let's say bromine, okay, it would have, if 1 mole of it, so 6.02 times 10 to the 23 of it, would be 79.9 grams. Why the difference? If it's the same number of atoms, why is it different mass? Right, bromine atoms are bigger. There are more protons, there are more neutrons, so there's just more mass there. Okay, I still have the same number, but it's like dealing with, I have 100 raisins, I have 100 bricks. Okay, like I have the same number of each, but obviously there's more mass in 100 bricks than there are in 100 raisins. Okay, all right, so that's the idea of the mole. Okay, this number here, remember we called this Avogadro's number, okay, because he's the guy who came up with it. Okay, and back, sorry you guys, that's not a hashtag. Back in the day that meant number. Yeah, hashtag this means number. Okay, yeah. All right, so moving on here, we were talking about how to use the mole equation. Now the mole equation sets up like this. N, which stands for number of moles, equals little m, which stands for mass, divided by molar mass. Okay, big M. All right. Number of moles is just moles, okay? Mass is always in grams, and molar mass is the mass of 1 mole, okay? So that'll be in grams per mole. And we looked at how to calculate the molar mass of things last week. All right, so we're going to look at today the 4 ways I can ask you a mole equation problem. There really are only 4 ways I can ask you a mole equation problem. We'll go over all 4 today, okay? So the first one is the most simple, and I think we did actually get to this one on Friday, but we'll go over it again anyway. How many moles of calcium chloride are in 90 grams? Okay, now, the way I've written it here is kind of I'm introducing you to this concept way. If I asked you this question on a test, would I give you the formula or the name in words? I'd give you the name in words because then I'm also checking to see whether you know how to drop and swap an ionic compound and all that kind of stuff. Okay. Whenever we're solving any kind of problem in science, the first thing we want to do is write down what the question gives us. We call those the givens. Okay? One of the things it gave us was the formula, which will allow me to calculate the molar mass. Okay? So we're talking about calcium chloride, okay? Which means I can calculate the molar mass of calcium chloride by looking up the atomic mass of calcium, which is 40.08, okay? And the atomic mass of chlorine, which is 35.45. But there are how many chlorines here? So what do I have to do to the 35.45? Times it by 2. Okay, when I do that, I should get that the molar mass is 110.98, right? I think so, grams per mole. Okay, so I've got that. And the other thing they gave me was little m. They gave me the mass in grams, okay? And it was 90 grams. So I have 90 grams of calcium chloride. 1 mole of calcium chloride has a mass of 110 grams. Do I have more or less than 1 mole here? Less. All right, so that's all right. We're going to get a decimal when we calculate N. The question is asking us how many moles are there. So we're looking for N, which means we don't have to manipulate the formula. It's already set up to calculate the number of moles. All right, so I plug in my numbers here. 90 grams was the mass, divided by the molar mass that we calculated, 110.98 grams per mole. Okay, so I got grams on the top, grams on the bottom. Those units are going to cancel and leave me with moles, which is good, okay, because that's what I'm looking for. Okay, and then 90 over 110.98 gives us 0.81 moles. All right, when you do a problem like this, I would suggest circling or putting a box around your answer. Okay, it makes it a lot easier to kind of track your work. If I see that the answer is right, I don't really need to look at your work too much. But if your answer is wrong, then I know I have an idea of kind of where in your work I need to look back to. Okay, so if you were looking at marks for this question, this would probably be like a 3-mark question. Okay, you'd get 1 mark for your givens and calculating the molar mass. Okay, you'd get 1 mark for your work because you didn't have to manipulate the equation. Okay, there's only kind of 1 there, and 1 mark for your answer. Next question. They gave it to me in the question. They said, how many moles of calcium chloride are in 90 grams? So it was one of the givens. Okay, questions on that one? Jacob? We'll go to 2. Yeah. Occasionally, I might give it to you in kilograms. It would only be other metric. I wouldn't give it to you in pounds or anything like that because that'd just be cruel. Okay, but yeah, there's an occasion where I might give you the mass in kilograms, but I mean, that's not a hard calculation. If I want to go from kilograms to grams, I multiply by 1,000. Yeah, okay, it's not. So we do expect you obviously to be able to do metric conversions pretty much in your head, okay, at this point. So if you're not familiar with the metric system, it's one of the things in your notes package. I think it's the first page or something like that. I put it in there, or in the workbook package, one or the other. Okay, looks like this piece of paper right here. Okay. All right, let's move on to the second one here. So, what's the mass of 4.5 moles of magnesium bromide? Okay, so this one is asking me to find mass, which is little m, right? Looking for little m. All right, so let's start out again, same as we always do. Let's write down our givens. What is the mass? Okay, so I know that little m is the question mark. Okay, of 4.5 moles. What did they just give me there? They gave me n, the number of moles. Okay, and they said of magnesium bromide, and this time in words. Okay, so if I'm going to calculate big M, I need to get the formula right. MgBr, this is a -1, this is a +2, so we're looking at MgBr2 for our formula. All right, now we can calculate the molar mass. So magnesium is 24.31, is that right? Yeah? Mine like a steel trap. Yeah. All right, so we got 1 magnesium and we got 2 bromines. So we got to add on to that 79.9 times 2. Okay, so we got 184.11 grams per mole. All right, that's the first step done. Okay, you'd get a mark for that. Now I need to calculate the mass of 4.5 moles. So the formula is not set up right now to calculate mass. Mass is on the top. I want to leave it there. I want to move big M. Right now I'm dividing by big M, so if I want to move it, I do the opposite. I multiply. All right, so I've multiplied this side, which made a big M on the top and a big M on the bottom, so they cancel. What I do to one side, I do to. All right, so there we go. Big M times N is going to give me little m. All right, get a mark for the manipulation. Okay, so little m, now we're going to plug in the numbers here. So that's going to be 184.11 molar mass, big M, times our number of moles, N, 4.5. Okay, so really what we're doing is saying, here's the mass of 1 mole, but I have 4.5 of them, so I got to multiply. Does that sort of make sense? Okay. All right, so we'll have 828.50, because we got to round it off here, 0.50 grams. To 2 decimal places, right? So I would round off there to 50, right? And that's grams. I almost forgot to put a unit on that. Okay, everybody all right with that one? Okay, those two are kind of like the one step. types that I can ask. The next one, the next two, will have an additional step involving Avogadro's number. Yep. Yes, you get a mark for it, so I want to see it. Yeah. Okay, any other questions on that one? Again, guys, it is super important to show your work. Okay, sorry, so you get a mark here for plugging in your numbers and a mark here for your answer. So this would be a 4-mark question. Here's why it's important to show your work. Okay, because every year someone says, oh, Mr. Kudar, I need to show my work. I can do this in my head. Good for you. If you can do it in your head, good for you. Here's the problem with doing it in your head. Sometimes your head makes mistakes. And if your head makes a mistake and you don't show me any work, how many marks am I going to be able to give you? 0. I don't want to do that. Write down what your head is telling you, please. Okay? Because I had a kid who did this on his Physics 20 final exam. He argued with me all year long about how he didn't need to show his work, and he wasn't going to. I said, okay. We reset the calculators before the final exam. He didn't put his calculator back into degree mode. Everything that involved the calculation with an angle was wrong because it was in the wrong mode. He almost failed his Physics 20 final exam because he was too arrogant to show his work. Okay? And this is a kid who realistically could have probably got 100. Okay? He was that smart, but he let it go to his head. Okay? Always show your work so that you can get part marks for stuff. Okay? Method is important. Because you know what? Sometimes you screw up on the calculator, right? You just, your fingers get clumsy, you type in a number wrong, but you've done everything else right. Why not get marks for everything you've done right? Okay? Seems like a no-brainer to me. Show your work. I can give you all the marks for the work. If you get the answer wrong, you only lose 1, as opposed to all of them. Okay? So always a good idea to show your work. Okay, any other questions on that one? Okay. So now we're going to need Avogadro's number in this one. Right? So in this question it says, how many molecules are in 600 grams of silver nitrate? So I'm not looking for moles now. Now I'm looking for molecules. I'm actually still going to need to find moles, though. Why? Right. Once I know how many moles are in 600 grams, I can use that, along with Avogadro's number, to figure out how many molecules there are. Because Avogadro's number tells me how many molecules are in 1 mole. Right. So if I always know that. Right. I always know how many are in 1 mole. So if I can figure out how many moles there are, then I can figure out how many molecules there are. Okay? So it's kind of like this. If somebody says to you, I have 3 dozen donuts, how many donuts do they have? They have 36. How did you do that? You multiplied 12, the number in 1 dozen, by how many dozen you had? 3, and you got 36. Okay? Wasn't a difficult calculation. We're going to do the same thing here. We're going to find the number of moles and multiply it by Avogadro's number, because that's the number in 1 mole. And then we'll get how many molecules there are. Okay? All right. So here's what we're given. We're given mass, 600 grams. What else are we given? We're given at least the name of the compound so we can find the formula, which means we can calculate molar mass. So silver nitrates. All right. This is a +1 and this is a -1. So that formula is already dropped and swapped correctly. Okay, 105 point something? 107, okay, 107.87. 107.87 grams. Then we got 1 nitrogen, so 14.01, and then 3 oxygen, so 16 times 3. Okay, so 107.87 plus 14.01 plus 48, that's 3 times 16. Okay, it's 169.88. Grams per mole. Okay, so I have mass and I have molar mass. What can I calculate right now? I can calculate the number of moles. I can calculate N, because I have 2 out of the 3 parts of that formula. All right, so N equals little m over big M. So that'll be our 600 grams. divided by 169.88 grams per mole. Okay, so we're taking the mass, we're dividing it by the mass of 1 mole to get the number of moles. Okay, so we got 3.53 moles. Okay. What do I need to do next? Because this question didn't want the number of moles, it wanted the number of molecules. Mason. Right. I'm going to take this number of moles. Okay, so I'm going to say number of molecules, and that's not hashtag molecules, we already talked about that. Number of molecules, okay, equals, okay, the number of moles times Avogadro's number. Okay, so we're going to take our 3.53 and we're going to multiply it by 6.02 times 10 to the 23. Now you're probably thinking to yourself, how do I put that in my calculator? Here's how. All right, so I'm going to take my number of moles that I just calculated here. I'm just going to keep that. And I'm going to multiply it by Avogadro's number. Whenever you use Avogadro's number, you need to enclose it in brackets. Otherwise, your calculator will try to do order of operations, and you don't want that. Okay? You have to try and outsmart your calculator here by using brackets. So I'm going to put a bracket up there. I'm going to put in the base number, 6.02. Okay? Now, your calculator has a special setting to do this times 10 to the power of 23, so you don't actually have to type in times 10, then the hat thing and the 23. Okay? I find that when people do it that way, they end up putting in an extra power of 10 for some reason. And so I try and avoid that. So what I do is I hit the second function button, and you see that my cursor turns to an arrow there, and then I hit the comma. Above the comma are 2 capital E's. Okay? When you do that, you get this little, you only get 1 capital E, I'm not sure why, but you only get 1, even though the button shows 2. Okay? You only get 1. That stands for times 10. And the next number you put in is the power, 23. So there's Avogadro's number entered on your calculator. Not every calculator is the same. Your calculator may have an EXP button. Okay? The EXP button will do the same thing. All right? So if you have that, you go 6.02, hit the EXP button, okay, and it'll give you an E, okay, and then you can put in the 23 afterwards. It may also have just an EE button, okay, so it'll be either EE or EXP. Those are the 2 buttons you need to look for. If you can't find those on your calculator, yeah, or you can use this one. Yeah, it's probably quicker to use that one. But, yeah. All right, because I find that when people do it that way, it puts in an extra power of 10, so it'll actually make it 24. Yeah. All right, so I'll take that, and then I multiply them out. All right, here's how many molecules I have. 2.13, okay, because we're only going to go to 2 decimal places. 2.13 times 10 to the 24 molecules. Oh, sorry, 2.13, rounding. 2.13 times 10 to the 24 molecules.
Which notation would you like our final?
You could put either one. Yeah, if you put an E there, I'll know what that means. Most of the time, this is the way we write it, typically. But okay. Oh, well, because when I multiply 3.53 by 6.02, it comes out to like 18 point something or something like, or sorry, it comes out to 21. So to keep it in this, they move the decimal 1 more spot over, right? So that's where the extra 20, where the extra power came from. It would have come out to 21.3 times 10 to the 23, but we always write it as a number between 1 and 10, right? So they move the decimal over 1 more. That's where that. What's that? It might not be. Like if this had been 1.2, it might not have gotten over 10, right? And then it would have stayed 10 to the 23. Okay, any other questions on that one? All right. Okay, last one. Last way I can ask you a mole equation question. Now I give you the number of molecules, and I ask you to calculate the mass. Okay, so if I give you the number of molecules, what can you calculate right off the bat with that? The number of moles, right? But now instead of multiplying by Avogadro's number, we're going to divide by Avogadro's number. Okay? It's like saying, hey, I have 48 eggs. How many dozen do I have? 4. Right? 48 over 12 is 4. Okay? We're going to go 1.54 times 10 to the 25 divided by Avogadro's number, and that'll give us the number of moles. All right, so let's write down our givens first off. Number of molecules equals 1.54 times 10 to the 25. Okay? And we know that it is diphosphorous tetraiodide. So that's P2I4. All right, so we got 30.97, yeah, 30.97 and 126.9. Times 2, is my 2 phosphorus, okay, plus 126.90 times 4. All right, this is a heavy, heavy molecule. All right, so we got our 30.97 times 2 plus 126.9 times 4. All right, so 569.54 grams per mole. Okay, so I've got big M, and in just a second, I'm going to have N, because I can calculate it by dividing the number of molecules by Avogadro's number. So that's my next step. Okay, so number of molecules divided by Avogadro's number. So that'll be 1.54 times 10 to the 25. Whoop, I wrote 24. I don't know why. 25. Okay, divided by 6.02 times 10 to the 23. Okay? Just looking at how different those numbers are, about how many moles do I probably have here? Okay, this is 2 factors of 10 bigger than this one. What's 2 factors of 10? At least 100, right? I'm going to have probably more than 100, okay? But I'm going to have at least 100 moles here, just looking at that number, right? This is 100 times bigger than this one because it's 2 factors of 10 bigger, okay, or somewhere in that neighborhood. All right, so let's have a look. Remember, whenever we're using numbers like this, they need to be enclosed in brackets. So I'm going to have the top number, 1.54 to the 25, in brackets, divided by Avogadro's number in brackets. Okay, what do I know? It was only 25. Oh, yeah, because this is 1. Sorry, I screwed that up. Okay. All right. Here's my reasoning. I looked just at the powers, okay? Something that's 2 powers of 10 bigger is like, that's a factor of 100, except that 6.02 is almost a full factor of 10 itself, okay? So anyway, we got 25.58 moles here. All right, now I know N, and I know big M. Can I calculate little m? Yes. Do I still need to manipulate the mole equation? Yes, I do. All right, so N equals little m over big M. All right, so I'm going to take that, and I'm going to multiply both sides by big M. Now I'm solving for M. All right, so little m is going to be 25.58 moles multiplied by 569.54 grams per mole. Okay, so I'm just taking N, multiplying by big M now. All right, a lot. Okay, we have a lot here. We have 14.5 kilograms of this stuff. Okay, so that's quite a bit. That's like just over 30 pounds worth of this stuff. It's a lot. Okay, so 14,569.63 grams. Now, should I write it out that long, or can I put it in scientific notation? Either one. It really doesn't matter that much. Out of force of habit, I always put big numbers in scientific notation. Okay, So I would go okay, or you could have written it also as 14.56963 kilograms. You could have also written it that way. Okay, either one would have been fine. All right, so a question like this has the most work to do. This is like a 5-mark mole equation question. Okay, so you'd have 1 here for the answer. You'd have 1 for that, 1 for that. Okay, so we're up to 3. 1 for calculating the number of moles, and 1 up here for your givens, 5 marks. Okay. All right, those are the only 4 ways I can ask you a mole equation problem. So if you can get familiar with those 4 question types, you will never see anything different. Okay, because that's the only things I can ask you. Now, granted, I could, do like little bits and pieces of one of those questions, but I mean, if I'm giving you a full problem and I'm going to give you ones just like that on your unit exam, that's what you're going to see. Okay? In fact, those were the ones that were on last year's unit exam. No, really, those are the only 4 ways that you can ask just a mole equation question. If I start putting it into a reaction like you would in Chem 20, then there are more ways. Okay, but that's a reaction stoichiometry question and not just a mole equation question. There's only it doesn't matter whether it's me or the government testing you, and the government's not testing you this year, right? But because there's only 3 parts to that formula, then add on Avogadro's number. There's only 4 things we can make you do, right? Alrighty. Okay, guys, just because I've seen this happen now on a couple of people's calculators, I need to stress to you, this is how you enter Avogadro's number. Okay, you use brackets 6.02, then you put the little e. Do not put another 10 in there. Okay, if you go 6.02 times 10, then go e 23, it's 10 to the 24. Because the e means times 10. So what you've gone and said is 6.02 times 10, then multiply that by 10 to the 23. Okay, you've put in an extra 10. We don't want that. It's just e 23. That's it. Okay, don't put in any extra 10s. That's what I was talking about before. People get all confused. They want to put in these 10s. Don't put in any 10s. Okay, because if I do it this way, I get this. But if I go 6.02 times 10, E23, whoop, not only does it, oh, I didn't put brackets, sorry. Look what I get, right? Not the same thing, okay? I want the top one, not the bottom one.